Section 8.4 Determinants and part of Section 8.5 Cramer's rule. Associated with every square matrix is a real number called its determinant. So the determinant is just another way to solve a system. And we can use, for example, in Chapter 7, we saw the elimination, substitution, and graphing methods. Then we saw that we could use matrices using Gauss-Jordan elimination in 8.1 and 2. In 8.3, we learned that we could use an inverse to find the solution to a system. And in 8.4, we're going to use determinants to help us solve a system. So the way we find a determinant is if we have a matrix, then the symbol for determinant is these straight lines that look like the absolute value. And so to find it, we're going to multiply A1 times B2 and then subtract A2 times B1. We also say that the value of the second order determinant is given by this. Okay, so evaluate the determinant of each of the following matrices. So here, the determinant, I can write this as two straight lines to indicate that I'm looking for the determinant, will be 10 times 5 minus 6 times 9. 10 times 5 is 50 minus 54. So this equals -4. Okay, so for letter B, the determinant here would be 2 times -5 minus -3 times 4. So we get -10 minus -12, and that's going to be equal to 2. For anything that is bigger than 2 by 2, there is a whole different process. And so for that process, it would look something like this, where we start with the first number here, A1. And if I was to cover this row and this column, so if I cover this row or this column and this row, then I'm left with B2, B3, C2, and C3. And that's what would be in here. Minus A2. So now if I cover this middle row and this column, then I'm left with B1, C1, B3, and C3. And then we're alternating signs, so then plus A3. So if I cover this row and this one, I'm left with B1, C1, B2, and C2. So that's how we would do it if we were doing it without a calculator. However, to save time, we can use a calculator. So in your calculator, you would go to matrices, second matrix, and I'm going to go ahead and edit a matrix. I'll enter it as letter D. And this letter C is 1, 2, 3, 4 rows and 4 columns. So enter the numbers. So we have 0, 4, 0, -3, -1, 1, 5, 2, 1, -2, 0, 6, 3, 0, 0, 1. So I quit, so I can quit, go back to matrices. We're going to do some math. So the DT, that's the determinant. So I press enter. And now I call my matrix. We put it in letter D. Enter. So the determinant for this, let me just call this letter A for that matrix. So the determinant of A is equal to -250. Okay, so how do we solve a system? So the method using determinants to solve a linear system is called Cramer's rule. And basically, the rule looks something like this. We have a system. and x is going to be equal to this here, and y is equal to this. And so just to break it down a little bit further, we can come up with three different determinants. So the first determinant is going to be your determinant of the coefficients. So basically we get a matrix made up of coefficients. In this case, we have a1, b1, a2, b2. And then for dx, that's going to be your constants. In this case, c1, c2, and the coefficients of y, b1, b2. And then dy is going to be your coefficients of a, and then your constants. Okay, so to solve the system, all this means here is that x is going to be equal to dx divided by d, where dx is the determinant of this matrix and d is the determinant of this matrix. And then y is going to be dy divided by d. So in this example, first we find the determinant of the coefficients, and then we're going to also find the determinant for dx, which is the constants and the coefficients of y. And then dy is going to be the coefficients of x and the constants. So here we would multiply 5 times negative 6 is negative 30 minus 12. So that comes out to negative 42. And then dx is equal to 12 times negative 6, which is negative 72 minus 96. Negative 72 minus 96 is negative 168. And then dy is 24 times 5, which is 120, minus 12 times 3, which is 36. So that comes out to 84. So to find the variable, the answer for variable x, we take dx divided by d, in this case negative 168 divided by negative 42, and that comes out to 4. And then y would be dy divided by dx. Okay, so let me repeat that. So the determinant of d is negative 42, the determinant of dx is negative 168, the determinant of dy is 84. To find x, we divide dx divided by d. And to find y, it's dy divided by d. dy was 84 and d was negative 168. So that comes out to negative a half. So my solution to this system is 4 and negative a half. Okay. If you wanted to put this into a calculator, then you would enter your letter D, which is A in this case, the B, and the C. So you would have to find the determinant of A, which is negative 42. And notice that's what we got here, negative 42. And then the determinant of B, negative 168, which is what we got here. And then you do the same for dy and you get 84. So once we divide those numbers, then we get that as our solution. Okay. So again, this is a process of getting the determinant if it's more than 2 by 2. However, I am going to allow you to use a calculator. So to get the determinant for this, we would enter it into the calculator. And I'm going to use letter E. Always remember which matrix you're using. This is a 3 by 3. So the numbers are 2, 1, 7, -5, 6, 0, -4, 3, and 1. Second quit. Now I'm going to go to math, select determinant, go find your matrix, 80. So let's call this matrix A. So the determinant of matrix A is equal to 80. And the same for this one, we would enter our information. So this is a 4x4. I think I already have it in here, but let's check. 0, 4, 0, -1, 1, 5. Yes, I already have it in here. So we're in the second quit, second matrix. Go to math, determinant, second matrix. I have it in letter D. So this would be equal to negative. Let's call this B. So the determinant of matrix B is equal to negative 250. So for this next example, example 4, it says use Cramer's rule. So again, to find, to solve the system, we need the determinant of the coefficients, the determinant of dx, dy, and dz. And these are the numbers that are represented by each of these matrices. So in this example, our first one would be the coefficients 3, -2, 1, 2, 3, -1, 1, 4, and 3. And then we would need dx, which is the constant 16, -9, 2. And then the coefficients of y, -2, 3, 4, and the coefficients of z. So 1, -1, 3. Then we need dy, which is the coefficients of a, the constants, and the coefficients of z. And last, we need d of z, which is made up of the coefficients of a, the coefficients of y, and the constants. 16, -9, and 2. So we would enter that into the calculator. And so to find x, we would do dx divided by d, y would be dy divided by d, and z would be dz divided by d. So for extra credit, on final exam, for 3 points, what is the answer for x, y, and z?